Solar electricity battery bank. If you're building your own solar power system, getting the best solar battery is a must. Solar batteries can be the best source of power storage and backup and can run everything in your house. With them, you maximize your ability to use the electricity generated by your solar panels on a day-to-day basis. During the times when you need more electricity than your solar panels are producing, you can use the solar energy you have stored. This guide will show you how to choose the best solar batteries for your home solar panels, small and off-grid system, and how to make the most of every amp hour of them. You can also find out more about how to wire multiple solar batteries together in the system to make them more efficient. At the bottom of this guide are some tips that will help you charge your batteries faster and ensure maximum service life. This is a long guide, so if you don't have time to read and learn, here are our picks of the best solar batteries on the market that you should buy. While there are many benefits from having a battery storage system to store the energy your solar panels produce, delving into the world of solar batteries can get confusing, particularly since they are expensive and are difficult to change after your solar storage system is built. Solar batteries come in many different types and sizes. Most people are familiar with the 12 volts battery system. This is simplest and most standard battery system that is used in vehicles, RVs, and boats, but in the world of solar energy it should be your choice only for a small simple battery system. By reading this guide you'll understand why. Figuring out how many batteries you need can be daunting. If you don't have enough battery capacity, you run out of power and need to fire up the backup generator. On the other hand, if you buy too many batteries, you add unnecessary expense to your system, with extra components, complexity, and maintenance. Sizing solar batteries is one of the first steps in designing your off-grid system. The amount of battery storage you need is based on your energy usage. Energy usage is measured in kilowatt hours over a period of time. The general goal when designing an off-grid battery bank is to get a system that is big enough to supply all your needs for a few cloudy days, but is also small enough to be charged by your panels. When is a standalone solar power system a good idea? Although the initial cost of an off-grid solar system is higher than a grid-tied solar system, off-grid solar systems can be a more economical choice in the long term, especially in remote places where you would have to have utility poles erected and bring power lines in to do a grid-tied setup. What size solar panel battery bank do you need for your home? The size of your solar panel battery bank is calculated with the answers to two key questions. Daily energy consumption. What is your daily energy consumption? How many days of autonomy do you need? If you plan on going off the grid, you'll want a solar panel battery bank that can supply enough electricity for your home to operate without any issues, so you need to know how much energy you use on a day-to-day basis. The less you consume, the more feasible it will be to install a solar panel battery bank. This is where an energy monitor comes in handy, but if you don't have one, you can look at your utility electric bill and make an estimate based on your total monthly consumption. Days of autonomy. Your solar panels won't always produce electricity. Cloudy or rainy days can significantly reduce your daily electricity output. On top of that, while your panels will only generate electricity for a few hours of the day, your home uses electricity constantly, even when you're sleeping. You need to decide how many days of electricity you want to have stored up so that your home has power even when your panels aren't generating energy. Most homes with solar battery banks aim for 3 to 5 days of autonomy. Battery bank capacity and power. Capacity is the total amount of electricity that a solar battery can store, measured in kilowatt hours, kilowatt-hour. Most home solar batteries are designed to be stackable, which means that you can include multiple batteries with your solar plus storage system to get extra capacity. While capacity tells you how big your battery is, it doesn't tell you how much electricity a battery can provide at a given moment. To get the full picture, you also need to consider the battery's power rating. In the context of solar batteries, a power rating is the amount of electricity that a battery can deliver at one time. It is measured in kilowatts, kW. A battery with a high capacity and a low power rating would deliver a low amount of electricity, enough to run a few crucial appliances, for a long time. A battery with low capacity and a high power rating could run your entire home, but only for a few hours. Depth of discharge, DOD. Most solar batteries need to retain some charge at all times due to their chemical composition. If you use 100% of a battery's charge, its useful life will be significantly shortened. The depth of discharge, DOD, of a battery refers to the amount of a battery's capacity that has been used. Most manufacturers will specify a maximum DOD for optimal performance. For example, if a 10 kWh battery has a DOD of 90%, you shouldn't use more than 9 kWh of the battery before recharging it. Generally speaking, a higher DOD means you will be able to utilize more of your battery's capacity. Factors affecting battery bank sizing. The number of batteries you use in your solar system depends on the following factors. The amount of money you have to spend on this solar project. Part of solar battery sizing is ensuring you can buy enough solar batteries to handle your power storage needs. You must also take into account the number of days you want to be able to go before needing to recharge your batteries. If you need to be able to power certain appliances for a specific number of days at a time without interruption, you'll need more batteries to carry a bigger load. This is determined by the number of batteries you use and how you wire them to affect your battery bank's total amp-hours, storage capacity. Another factor that affects solar battery sizing is the amount of power you will be needing for all of your appliances. If your appliances require many watts, power, you'll need enough batteries to store the power so you can use those appliances. Another factor that affects the size of your battery bank is the amount of volts your solar system produces. If your system produces 48 volts, then you're going to want to have enough batteries in your battery bank to store 48 volts. Actually, a little less is better, like a 36-volt system with a 24-volt battery bank, just to be sure your system can charge the battery bank even in the case of a sudden voltage drop. When sizing a battery bank, always size your solar panels bigger than your battery bank to be able to compensate for factors such as voltage drop, power fluctuations, and energy loss due to wear on the system. To charge a battery, a generating device must apply a higher voltage than already exists within the battery. That's why most PV modules are made for 16-18V peak power point. A voltage drop greater than 5% will reduce this necessary voltage difference, and can reduce charge current to the battery by a much greater percentage. Our general recommendation here is to size for a 2 to 3% voltage drop. So for a 12-volt battery bank, a 16-18V solar panel should be used to allow for unexpected voltage drop. Another important consideration when sizing a battery bank is the storage capacity you will need your battery bank to have. If your area gets less hours of sunlight in the day, you're going to want more batteries so you can store more amp-hours of power in your reservoir and last out the long night stretch. When sizing a battery bank, the more amp-hours you have, the longer your total power reserve would take to deplete. When doing solar battery sizing, you must also take into account the rate of discharge you want to have. Remember, the slower your batteries can discharge, the more hours you'll get out of them. You can find out a battery's rate of discharge by looking at it and finding the value marked C. If you see C10, then this means the battery takes 10 hours to discharge fully. If it's C5, then the battery takes 5 hours to discharge fully. Lastly, when sizing a battery bank, you must consider the depth of discharge you want to go to before recharging. This is decided by your specific power need/capacity and affects the battery's lifespan. Basically, the bigger your batteries are and the more batteries you have, the more convenient it is for you and the better it is for your battery's health. This is due to the fact that with more battery/storage capacity you will have more power available, plus you will be discharging your battery bank in smaller, more shallow cycles and thus increasing its overall lifespan. Therefore, as a general rule in solar battery sizing, it's always better to have more batteries in your battery bank and only discharge them 30 to 50% of the way down, than to have less batteries and discharge them more. Use a battery bank sizer calculator that can help automate the process for you. Round-trip efficiency. A battery's round-trip efficiency represents the amount of energy that can be used as a percentage of the amount of energy that it took to store it. For example, if you feed 5 kWh of electricity into your battery and can only get 4 kWh of useful electricity back, the battery has 80% round-trip efficiency. 4 kWh/5 kWh equals 80%. Generally speaking, a higher round-trip efficiency means you will get more economic value out of your battery. Battery life and warranty. For most uses of home energy storage, your battery will cycle, charge and drain, daily. The battery's ability to hold a charge will gradually decrease the more you use it. In this way, solar batteries are like the battery in your cell phone. You charge your phone each night to use it during the day, and as your phone gets older you'll start to notice that the battery isn't holding as much of a charge as it did when it was new. Your solar battery will have a warranty that guarantees a certain number of cycles and/or years of useful life. Because battery performance naturally degrades over time, most manufacturers will also guarantee that the battery keeps a certain amount of its capacity over the course of the warranty. Therefore, the simple answer to the question "how long will my solar battery last?" is that it depends on the brand of battery you buy and how much capacity it will lose over time. For example, a battery might be warranted for 5,000 cycles or 10 years at 70% of its original capacity. This means that at the end of the warranty, the battery will have lost no more than 30% of its original ability to store energy. Manufacturer. Many different types of organizations are developing and manufacturing solar battery products, from automotive companies to tech startups. While a major automotive company entering the energy storage market likely has a longer history of product manufacturing, they may not offer the most revolutionary technology. By contrast, a tech startup might have a brand new high-performing technology, but less of a track record to prove the battery's long-term functionality. Whether you choose a battery manufactured by a cutting-edge startup or a manufacturer with a long history depends on your priorities. Evaluating the warranties associated with each product can give you additional guidance as you make your decision. How long do solar batteries last? There are two ways to answer this question, and the first is to determine how long a solar battery can power your home. In many cases, a fully charged battery can run your home overnight when your solar panels are not producing energy. To make a more exact calculation, you'll need to know a few variables, including how much energy your household consumes in a given day, what the capacity and power rating is for your solar battery, and whether or not you are connected to the electric grid. For the sake of a simple example, we'll determine the size of a battery needed to provide an adequate solar plus storage solution with national average data from the U.S. Energy Information Administration. The average U.S. household will use roughly 30 kilowatt-hour, of energy per day, and a typical solar battery can deliver some 10 kilowatt-hour of capacity. Thus a very simple answer would be, if you purchased 3 solar batteries, you could run your home for an entire day with nothing but battery support. In reality, the answer is more complicated than that. You will also be generating power with your solar panel system during the day, which will offer strong power for some 6 to 7 hours of the day during peak sunlight hours. On the other end, most batteries cannot run at maximum capacity and generally peak at a 90% DOD, as explained above. As a result, your 10 kilowatt-hour battery likely has a useful capacity of 9 kilowatt-hour. Ultimately, if you are pairing your battery with a solar PV array, 1 or 2 batteries can provide sufficient power during nighttime when your panels are not producing. However, without a renewable energy solution, you may need 3 batteries or more to power your entire home for 24 hours. Additionally, if you are installing home energy storage in order to disconnect from the electric grid, you should install a few days' worth of backup power to account for days where you might have cloudy weather. Solar battery lifespan. The general range for a solar battery's useful lifespan is between 5 and 15 years. If you install a solar battery today, you will likely need to replace it at least once to match the 25 to 30-year lifespan of your PV system. However, just as the lifespan of solar panels has increased significantly in the past decade, it is expected that solar batteries will follow suit as the market for energy storage solutions grows. Proper maintenance can also have a significant effect on your solar battery's lifespan. Solar batteries are significantly impacted by temperature, so protecting your battery from freezing or sweltering temperatures can increase its useful life. When a PV battery drops below 30 degrees Fahrenheit, it will require more voltage to reach maximum charge. When that same battery rises above the 90 degrees Fahrenheit threshold, it will become overheated and require a reduction in charge. To solve this problem, many leading battery manufacturers, like Tesla, provide temperature moderation as a feature. However, if the battery that you buy does not, you will need to consider other solutions like earth-sheltered enclosures. Quality maintenance efforts can definitely impact how long your solar battery will last. What are the best batteries for solar? Batteries used in home energy storage typically are made with one of three chemical compositions: lead acid, lithium-ion, and saltwater. In most cases, lithium-ion batteries are the best option for a solar panel system, though other battery types can be more affordable. Lead acid. Lead acid batteries are a tested technology that has been used in off-grid energy systems for decades. While they have a relatively short life and lower DOD than other battery types, they are also one of the least expensive options currently on the market in the home energy storage sector. For homeowners who want to go off the grid and need to install lots of energy storage, lead acid can be a good option. Lithium-ion. The majority of new home energy storage technologies, such as the, use some form of lithium-ion chemical composition. Lithium-ion batteries are lighter and more compact than lead-acid batteries. They also have a higher DOD and longer lifespan when compared to lead-acid batteries. However, lithium-ion batteries are more expensive than their lead-acid counterparts. Saltwater. A newcomer in the home energy storage industry is the saltwater battery. Unlike other home energy storage options, saltwater batteries don't contain heavy metals, relying instead on saltwater electrolytes. While batteries that use heavy metals, including lead-acid and lithium-ion batteries, need to be disposed of with special processes, a saltwater battery can be easily recycled. However, as a new technology, saltwater batteries are relatively untested, and the one company that makes solar batteries for home use, Aqueon, filed for bankruptcy in 2017. Conclusion. Solar batteries are simply deep-cycle batteries that provide energy storage for solar, wind and other renewable energy systems. They are a key component in an off-grid solar energy system. In other words, solar batteries are the heart of a solar PV system. Even if you're installing solar panels on the roof of your house or your RV that are already tied to the utility grid, you'll still need solar batteries if you are trying to use power in the event of an outage. Without solar batteries, you can only use power at the time solar panels produce it. Solar batteries work by storing the DC energy being produced by your solar panels during the day and make it available when the sun isn't shining. In most cases, you have to use a power inverter with your batteries to convert DC electricity into 120 volt or 230 volts AC for use in the home. Overcharging is the enemy of any deep cycle battery. Your solar batteries also need a solar charge controller to manage the power from solar panels going into them. A solar charge controller ensures that the batteries are not overcharged during the day, and that the power doesn't run backward to the solar panels overnight and drain the batteries. Which type of solar batteries is best? For many years, solar storage systems mainly relied on lead-acid batteries. They were individually designed and often involved significant installation time and cost. Solar batteries on offer today are packaged as large single or small modular units, can be flooded lead-acid, sealed lead-acid, AGM or gel cell, lithium-ion or several other chemistries, can store much greater amounts of energy in a smaller volume. In most cases, lithium-ion batteries are the best option for a solar panel system, though this type of deep cycle batteries is still relatively expensive and can cost you a lot more than other types. Flooded lead-acid batteries are the cheapest option, but they have a short cycle life, 500 or less, and require a bit of maintenance. To choose the best solar battery type, it is important to understand the advantages and disadvantages of each type, its upfront cost, and especially to make sense of what is covered under the warranty. Please visit informational solar website or internet store of the PWM company. The PWM info website for investors, http://solar.pwm.company. The PWM e-store and products lines of the company, http://pwm.company. The PWM contact email, guru.pwm@gmail.com. Please subscribe to the channel of the Solar PWM company, like and share this video.